So today I thought we'd come out and have a look at an installation in the field so you can see actually what happens. So this is an example of a Puffin Crossing, and what I'm going to do is take you around, have a look at the various features so that you can see what makes up one of these installations, and take you through the sorts of items that I would look at a commissioning inspection. So we'll be looking at the civils elements, where the equipment is, and compliance with the various requirements that we have to fulfill for not only traffic signal offsets and things like that, but also for compliance with the Equality Act, etc. as well. So there's quite a lot involved, but I think you'll find it interesting to see what actually happens. And it may get a bit noisy. I can't predict what traffic's going to be around, so you'll have to bear with me on that one. Anyway, I'm Alistair, and this is at ITS Now. So this Puffin Crossing is a Siemens, a Unix, still badged Siemens on here. Puffin. Some people will recognise where this is, but I'm not going to actually say. But before I start looking at the equipment in detail, what I'm actually going to do is go and look at the civils aspects, because that's what I would be inspecting to start with. So let's go and look at those. So the first item I'm going to look at is the detector loops. This one, you see that we're set back from the actual signals themselves. There's a pair of loops here, so I presume these are speed assessment loops. That's because this is in a 40-mile-an-hour speed limit, and we'll look at speed discrimination, speed assessment in another episode. But what we would need to do is actually take the measurements for this. So what I will be looking at is the distances from the leading to trailing edge of the loops. The distance from here to here longitudinally, and then also the offset distances from the curb line to this edge, and then from the other edge of the loop to the centre line, or the lane marking. So that's one. And then the other critical element is also the distance, the gap between the two loops. So we've got this loop here, a gap, and then a second loop here. So we need to know that that gap between the two loops is actually compliant with the requirements. And then I'd also measure this loop as well, same as the first one. And then what we want to do, what I'd be doing, you can see these are cut back. So you see this extra line between the twin yellows to here, and that goes into this chamber here. So there'll be a joint in this chamber. So I'd have that lid off, check that the chamber had been constructed properly, that the ducting is properly done, that the frame for the cover is actually secured properly to the chamber, so to the design standard details. And then the next thing I would also do is also measure the distance from here up to the stop line. Now that's an important aspect of speed loops, because the whole way that speed assessment and speed discrimination works is reliant on those measurements being accurately made when they were constructed. So, right, next items. So we've got some more loops here. We can see these are in a chevron shape. there's actually 3. So these are system D, X, Y and Z loops. These should be at 12, 24 and 39 meters from the stop line. And that measurement is actually taken from this corner here. Not from the closest corner, not from that side. So it's the curbside leading edge corner here, which is that key measuring. And again, what I would be doing is measuring the length of this loop. It's not as critical for these because we're not doing any timings, but just to make sure that they've been put in properly. And again, the offsets between the centre line or the lane line and the offset between the curb and this edge. And again, here you can see the cut back here going into this chamber. So I'd be checking the joints, checking the construction of that chamber as well. And although it would seem, well, those are bound to be fine, numbers of times that I've seen issues with these, it is definitely worth doing. So I do that on both sides, check the location and way in which those have been cut. Another element which is necessary to look at fairly early on is the road markings. So this is a standalone Puffin, so it's got the zigzags on the approach to warn drivers that can't have those if it's part of a junction, signalised junction. Now on this one you can see that on this side, centre and this side, near side, there are actually 10 sets of zigzags. But on the far side, actually it stops short, there's only 8. And the reason for that is because there's a public parking area over there. So they've allowed people to drive into that, because you're not supposed to come off to the side. Now, actually, this is an interesting point. So the Z loop, there's a couple of items I noticed with this immediately. Actually, the offset between the far side of the loop and where the centre of the carriageway is actually is quite a long way this way. Sometimes that's done on purpose if there is turning traffic or anything, but you see this is a straight road, so that's not the issue. But the more concerning item I have with this is that chamber lid in the middle. Now that's not actually very far away from the edge of the loop. You're supposed to have a minimum of a metre gap between a loop and any ironwork in the carriageway. That's so that the loop doesn't get set off if the chamber lid moves for some reason, gets loose and starts setting off the loop, and you then start getting false detections or issues. It doesn't settle down. So that is something I would have wanted to have sorted out. And I think, given that it's just System D in this situation, it would have been totally appropriate just to move that loop slightly closer to the stop line. That would have still provided the vehicle extensions and would guarantee getting through the stop line, but would have overcome that proximity to that chamber. Okay, so we've got the zigzags on here. You can see that the departure lane and then these two on this side are in opposite directions. So that's permissible and actually provides a bit of a speed benefit. It reduces people's driving speed. I Okay, really important, probably one of the most important aspects of a traffic signal installation is the stop line. Now this is a nice wide one, looks like it's 300 millimeters wide, so that's okay. 40-mile-an-hour speed limit, so you want to look at that. So there are a couple of things here that I would be measuring. The distance from the stop line longitudinally to the stud line, so that's the edge of the crossing. So really want to have a 3-meter gap offset or distance between those two here. And then at the crossing itself, we'd be looking at the crossing studs. So in this one, we want to look for a nice straight line between that continues from the edge of the tactile paving across and onto the tactile paving the other side. I would say actually this is just slightly skew on this side, but I think that's acceptable. I don't think anybody would actually notice that. The issue normally comes if the curb line itself is at an angle for some reason because of the geometry of the road, and then the tactile pavings are put in behind that so that they don't line up with the stud line. So this is here to guide visually impaired people correctly across the crossing. So that's why it's so important that this is in the right orientation. The other thing with this, probably one of the most problematic items that you get, is that the stem for the tactile paving is on the right hand side of the approach, and then you've got this piece, the lateral piece across for the full width of the crossing. The reason for that is that is here to guide visually impaired users to the location of the push button. So that can be a bit of a problem on one-way streets where actually the traffic will be approaching from this side, so you'd have to have the full push button on this side of the road. But if that's the case, you'd have a small demand unit in this case, in this side, as an additional. So with this, we can see that the stud line again is aligned, and then we've got the distance from this side to the other stop line. What I'd then go and do is look at the other approach, the same as we've just done on this one, and look at the system D and any other loops that may be on this one. Right, so next thing is the distances, the offsets for the push button units. Now again, this might seem quite petty, but it's really important that this is done right. So I would literally be getting my tape measure out and making some measurements. So on the ground here, we've got 500 mil, which actually lines up with the location of the push button unit. And we also want to look at the offset to the curb line. So again, if we take that down at ground level, actually in this case it's just over 500 mil. It's important, there's a minimum clearance distance for roadside equipment from the face of the curb into anything has to be a minimum of 450 millimeters. In this case, you can see that they've actually put the signal heads inboard of the signal pole, so we don't get any overhang from the signal backing boards and things. So that's really important. So this one, that's fine. We've got this distance. The other thing is to measure the distance from the centre of the push button unit down to the footway. Now, chapter 6 says that the distance should be 1 metre, but it incorrectly says to the bottom of the unit, not to the centre of the push button. The tolerance is 1 metre minus 0 millimetres plus 100. So quite a few local authorities say that this should be at 1050 millimetres height. Anyway, that's what's going on with that. So we need to make sure those offsets, lateral, both from the side of the crossing itself and from the carriageway, are correct. The height is correct. The angle of the push button unit itself should be about 30 degrees, so that when you're stood at the crossing, you can actually stand here and not only see the indicator, but then also look at approaching traffic. There we go. Someone's just gone over. So that's quite important to get that right. On the back of the unit, we also need to check if this is sealed. So you'd be getting your T key out, opening this up. This front folds down, and then you look inside, and the cable that goes into this unit on these is terminated in the base, comes up and into the back of the push button unit. Once that's in, there's a grommet around the outside of it, but if there's any condensation on the inside of the screen, there's anything, any sign of damp, usually what's happening is water's running down either the inside or the outside of the pole onto this. So this pole is a wide base, low entry steel pole. So you've got this bulbous bit at the bottom, so it means we don't need to do any cable terminations at the top of the pole. But at the top, the pole cap is a vented plastic cap, so if there is any moisture that gets in from the duct system, it tends to get drawn up by the warmth of the pole, and then it gets vented out the top rather than sitting inside the pole and then rusting. So with this one, we've got a D bracket on the side of the pole with the two heads mounted on either side. So this is what we'd refer to as a 2-pole 4-head. So you've got primary for this approach, and then diagonally across on the other side, the secondary for this approach, and the same vice versa for the other side. And then on the top, you can see the on-crossing detector. So quite often on a Puffin, you'll have 2 of these units on top of this pole. On this, they're just using on-crossing, so it detects the presence of pedestrians on the crossing and can extend the clearance time so that for people with mobility issues or whatever, they've got longer to actually cross. The other unit that you will see on Puffins is a curbside detector. So it will detect this zone here. So anyone that comes and presses a button, if they then walk away or cross before the demand matures, then it will cancel it, so it doesn't stop traffic unnecessarily. So the last thing on these, you can see that the poles are in retention sockets. So if they do get damaged or need to be replaced for some reason, it's easy to lift these out and then put a replacement in. What is important though is that surrounding that retention socket should be a large cube of concrete that's poured in to support this. And it's really important that that has been put in big enough so that if the pole is struck by an errant vehicle, that won't move. Otherwise, it's a waste of time. It won't actually do anything. Okay, so on this side, just looking at the curbing, we can see that the curb is flush with the carriageway surface, but even in the short duration of time that this site has been in, we're getting grit and silt accumulating in this section, and similarly in the corners on the far side as well. We're also getting an issue with that. Now, that's often indicative of ponding, so when it rains, water accumulating there and just sitting there in a puddle, which isn't a very good situation. And actually, if we look along this section, there are no drainage gullies on either side. The crest of the hill appears to be just slightly further on. It's fairly flat, but water will be running past here and going off down that way, but it's not going to be, it's basically going to be sat around, so anybody using this when it's wet is going to get wet feet. So not a very good situation. Right, cabinets. Great to see this is on an elevated base. That means that I am pulling cables, doing maintenance, adding features to this in the future are much easier. If we need to replace the cabinet, it would be possible to do that without having to extract the whole thing out of the ground. We've got the master chamber here, so all the cables will be pulled back to this point and then go in through the base of the cabinet and up through and be terminated internally. And then on the side there, we've got the electrical feeder pillar. Now walking around this, so this has got an antenna on it. So I would assume that because this is a Puffin, that's just used for fault monitoring primarily. It would mean that the site can be interrogated remotely as well. And then on this side, you've got the police panel. So that allows access to basically turn the site on and off for a crossing like this. So we can just see in here the manual panel. It's quite simplistic on a Puffin Crossing, but you've got a couple of selectors on here and you can switch the signals on and off as well. Put that's off. Right, within the controller cabinet we've got cables coming in from each of the poles, so they've split them, signals and push buttons by the looks of it. And in here you can see ST750 extra low voltage, so this is the brains of everything. We've got the phase drives here, and we've also got an outstation, so this reports back if there's any issues and can be interrogated. And then up the top here we've got the detector packs as well, so you can see actually they've commoned the system Ds together, and then it's labelled SDE 1, 2 and 3, so I think that must be speed assessment rather than speed discrimination. Anyway, so and you can see all the terminations. Now with all of these, it's really important that things like these idents are correctly put on. So each core should be identified, and that should happen within the poles, within push button enclosures, etc., so that they're not misconnected at some point in the future. And you can see on these, you've got these yellow tags in here which are identifying what is what as well. Those are yellow, so those signify that they're extra low voltage. You can see at the back there's a red one, so those are mains. I assume that's actually the incoming mains to the main isolator. And in some locations you may see a green one as well, which is usually used for detector loops, etc. So that's a brief view of what's going on. In the bottom you can see the base. The cables come in through this glanding plate, so rather than having an epoxy seal, this provides the environmental barrier from the outside into the cabinet, so stops water upwelling through the base, or also stops things like rodents and insects getting in there. One thing I would say with this, they've put in a number of cables at the back all through a single gland, which means that isn't actually sealed, so I don't think I'd be that happy with that one. Those are the deck cables. I think I would have wanted those brought in individually if it was mine. Anyway, so and then you've got the door pocket with the details of the site, handbook, etc. So that's a brief look at the sorts of things that we would be looking at for an installation when we're out doing a commissioning assessment and inspection, prior to actually doing the functional testing, making sure that the equipment is configured to the desired requirements and that everything is working. But it really is critical. I think a lot of the time people don't understand the importance of actually verifying the physical attributes of a site and measuring things, checking things go to the right place, etc.
Remember to hit subscribe for ITS now.
Right, so the last thing, before leaving site, we always make sure that things like the cabinet doors are closed and secured properly, so those are all done. Right, the last observation with this site, I think it's quite an interesting one, and that's about use of it. We can see there's a route through into this field, which is only just down from a major footpath on this side. But directly opposite, on the other side, is a pathway. And you can see, looking at the grass here, that quite a few people are obviously crossing the road just short of the crossing location. So this is actually the pedestrian desire line. Now, if you look at this location, that is the attractor. That's the reason that this crossing is in place, because there's a secondary school over behind these houses. There's a new housing estate being built in on this side with a junior school. So there are kids from the estate, the new estate which is being built and getting bigger and bigger, coming over to go to the secondary school through there. There are also children on that side of the road who are coming across to go to the new junior school on this side. So I think it's quite obvious that actually this crossing is in the wrong place. It should have been just a few meters further down onto here. Now you think, well, is there a reason for that? Now there could be things like over there's a driveway for a house, but I don't think that would have been an issue particularly in this situation. It's not like it's commercial premises. Yeah, I don't see a good reason why that couldn't have been just put here. So that's one of the sorts of things that need to be thought about when actually doing those initial assessments. Where should the site be? So I think that's an interesting insight to what happens out on site. We've seen this one is a pretty good installation. It's a new site, newish anyway, it's only been recently installed. And so, you know, it should have had scope for being absolutely perfect. Now the reality of the situation is that things creep in at all stages. So whether it was the original assessment, the design stage of the installation, during the construction, so it's difficult to tell. You know, I've had no involvement with this at all. However, I think there are a couple of minor things that we found during this, and I think those are examples of the sorts of issues that are faced in reality. So, hope you found that helpful and interesting. I'll see you next time.